Hello, my name is Ethan Hunt, and today I'm going to be talking about how to create a graph using your Beer's law analysis, uh, mapping a best fit line on that graph, and how we can work backwards, say give or when given an absorbance, calculate the concentration. So hopefully after your lab, you should have some data that looks like this. This is just some sample data I generated. Your data probably should have, it should be a little bit more messy, right? Shouldn't just have these round numbers like I'm working with here. But for the sake of example, this is the data we're going to use. We've got two columns here. We've got concentration in parts per million and absorbance. And so we want to create a graph so that, say, when we're given an absorbance, we can determine what the concentration in parts per million should be. So to do this, to create a graph in Excel, we want to select the table we're working with, the data we're working with. Select what we're working with. We're going to go to Insert at the very top here. We're going to move over to the Charts section, click on Recommended Charts, and we want a scatter plot. So we're going to click on Recommended Charts. We're going to go to All Charts, and you should see on the side here XY scatter. I'm going to click on this, and you're going to click on this one here where you see this kind of step up with data. We don't want this one that's got two different sets of dots. We just want the two dots combined here. So we're going to click this graph. We're going to click OK, and it's going to pop up here. Now, say I'd like to print off this graph, or I'd like to make it. I'd like to have its own tab, right, where it just contains this graph. Let's say that we want to do that. What we're going to do is we're going to click on this graph. You should see Chart Design pop up, and in the Chart Design tab, you should see Move Chart. We're going to click on this. We're going to click on New Sheet, and we're going to label it Beer's Law Chart, for example. And we're going to click OK. And now you can see at the bottom here, this is where we had our original data. But now we have a tab called Beer's Law Chart, which has the chart we created in the earlier step. So I'm just going to move this over to the front. I might as well rename this Data, just so that if we do send this to maybe our boss or something like that, or if we send it to someone, they know exactly what each tab means. So now that we've got this chart here, we want to it's a little bit plain, right? There's not much explaining what's going on. And again, if we gave it to our boss, if we gave it to someone, they'd have a really hard time determining what this chart means. So let's give this chart some labels here. So what we're first going to do is we're going to change the name of the chart. We're going to call this Beer's Law Analysis. Right? And now we also maybe want some axis titles, right? What does this axis mean? What does this axis mean? So we're going to go up to the top here of this chart. You're going to see this green plus, and all these chart elements are going to pop up. We're going to click on axis titles. And so we're going to rename the y-axis here to absorbance, and the x-axis to concentration and parts per million. Great, so now that we've got a nice labeled graph, it's really easy to read and we can kind of understand what's going on. We want to figure out what the line of best fit is for this graph. Now normally, if you're doing this by hand, what you would do is you get your ruler out and you would try and plot a line that goes between all these points, and the line is supposed to be equal distance away from each of these points. However, in practice, it's very hard, right, to manually figure out what this line is. Luckily, Excel has a feature that will calculate the line of best fit for you. So again, we're going to click on this chart, click on the green plus sign here, and we're going to go down to trend line here and click check, and you can see that Excel will map out a line of best fit for this data. Now this is great, but what if we want to do some algebra? What if we want to do some analysis to determine, say, if I was given an absorbance of 5, what would be the concentration? And manually, kind of holistically, what we can do is we can look at 5, follow the line at 5 until it hits the trend line, and then we can go down and we can determine that our concentration should be somewhere around here. This looks like 5.7, for example, right? However, the issue with this is that we can't get a specific answer, right? I'm just kind of estimating 5.7, but what if we want an exact answer, right? So what we're going to do is, still in this chart elements tab, we're going to click on the arrow next to trend line, and this extra menu is going to pop up. We're going to go to more options. Now, this is an advanced, well, maybe not advanced, but this is just more detail on how the trend line is being calculated. We want to ignore most of this, and we want to go down here to display equation on chart. And now you can see that Excel has done the algebra for us and has determined both the slope of the line, the 8.8 here, and the y-intercept, the 0.05. So this is the equation of our best fit line. What we're going to do is we're going to double click until we select all of this equation. Control C, or we're going to copy it. We're going to go back to our data here. And in D1, we're going to paste. And I'm going to right align this just so that it doesn't go into the C column. So now that we've got this line of best fit, let's maybe change the variables around so it makes a little bit more sense to us. So we're going to copy and paste that in the cell below. Now our y variable was our absorbance, so we're just going to change that to A. And our x variable was our concentrations. We're going to change that to C. So now we have an equation we can use. When given either a concentration or absorbance, we can calculate the other figure using algebra. So, for example, say we're given an absorbance of 5, like I was talking before. We estimated it that it was around, if I remember correctly, we estimated that it was around 5.7 or 0.57 rather. So we want to determine maybe what's the exact concentration as per our line of best fit. Well, if we copy our formula down here, right, this is algebra. So we're given an A, so what we can do is we can replace this A in our equation with 5. And now what we have to do is solve for C. Now, if you were doing this on hand, what you would do is first you would subtract 0.0516 from 5, and then we would divide by the 8.8387, and that would give us our C. So right here, I'm going to do just that. We're going to do bracket 5 minus 0.0516. And notice this is in brackets because we want Excel to do the subtraction first before it divides by the 8.8. So then we're just going to divide by the 8.8387. And so again, what we're doing is we are rearranging this equation to solve for C. And so when we hit enter, we can see that if maybe let's round this number to the nearest 2 decimals, for example, we can see that our line of best fit predicts that if the absorbance is 5, the concentration in parts per million will be 0.56. That's it for this video. I hope it helped. Thanks for watching.